number 1, we needed to simplify this. How would we do that?
Multiply.
Multiply what?
6x with -2x.
Okay, so 6x times -2x would give us
-12x.
-6x times 3.
-18x.
Positive 18x. And then what?
-5.
Okay, and what would that be?
Positive
10x. And then, and that would be what? So our final answer was what?
-12x squared plus 28x.
So remember that one can be written in different words, or the directions may be different. It may say simplify, it may say find the product of, multiply, any of those, you're doing the same thing. Questions on that one? Number 2, you needed to combine like terms, so distribute everything. We have 2x minus 3y minus 12x plus 3y, and then our plus 6x at the end. Combine all of your x's together. So we have negative 10x plus 6 would be negative 4x.
Why is it 2? Why is it
It's
negative
6.
6?
Should definitely be 6.
Oh.
Yep. Minus. Sometimes I miss numbers when I'm supposed to work. Okay, and then combine all of your y's. So negative 6y plus 3y will give us negative 3y. Questions on that? For number 3, it's asking which of these points are not solutions. The easiest way to see that is to graph them and see do they fall in the shaded area or not. So negative 2, 4 is definitely a solution because it falls in the shaded area. 0, 3 falls on the line, and this is a dashed line, so that would not be a solution. And 5, 1 did not fall in the shaded area, so that was also not a solution. Questions on that? On the back. For number 4, there were a couple different ways you could go about doing this. The easiest one would be to start at the point 4, negative 1, and use your slope of negative 3, 2 to go backwards and find your y-intercept. So if I go up 3 and to the left 2, and I keep doing that, I would end up at 1, 2, 3, 4, 5. So our equation would be y equals negative 3 over 2x plus 5. Algebraically, you could have used your point slope formula and put that in. That's what your y-intercept is. So when we went backwards, that's where we ended up. For number 5, we needed to graph this. So start at negative 1 and go up 2 to the right 1 as many times as possible. And down 2 to the left 1 as many times as possible. This would be a dashed or a solid line. Solid, because it is equal to. And this would be shaded above or below? Below, because it's less than. So below would be anything below the y-intercept, so all of this. Questions on that? Right. We are going to go through the next set of notes. we kind of have started talking about this as we've been reviewing for the SOL already. But now when we talk about it, hopefully we will keep all of this in our minds and things like that. So everyone should have these notes in front of them. Alright, so briefly when we talked about transformations, we're talking about how we compare the y-intercepts and the slopes. And we're doing the same thing here. If we have something that shows that we are adding or subtracting outside of the function, or that's our y-intercept, really our y-intercept is changing, so we can say that. And all of these are always comparing them to an original function, which is f of x equals x, where your y-intercept is 0. So if you want to write that somewhere up here, you can. So if it was 0 and it's now being moved up 2, we can say that this was shifted up 2. Somewhere on your paper, if you want to write, just so you remember, anytime it shifts up or down, that's dealing with your y-intercept. I'm just going to write that at the top. With this, it's a little different because your y-intercept would go up 2, but it would also move every single point along your function up 2 as well. So really your entire function shifted up 2, but your slope didn't change. So really your y-intercept is the only thing that changed. What questions do we have on that before we continue? For number 2, anytime we are multiplying a number to the function, that is changing your slope. So I'm going to write that up here. And since we are always comparing it to this original f of x equals x, we're comparing the slope of 1 to whatever the slope may be now. Multiply and the hashtag number sign. I just put number because it could be whatever number. Now, if you want to be even more specific, you could write this. If the number you're multiplying is less than 1, so not a negative, but is less than 1, like a fraction, that new function is going to be less steep. If you have a number that is greater than 1, that new function will be steeper. I should say, this shouldn't say equals, it should say less than 1. So if we're multiplying this 1/3 to our function, our slope is changing, and would that new function be less steep or steeper? Less steep because it's a fraction, because it's less than 1. would be less steep. You could say it's 1/2 the slope of the original. It could be written different ways. There is one other that I don't think is on here, but I'll say this also so you have it. So, up or down for your y-intercept, multiplying your slope, just looking at the number itself, that has nothing to do with if it has a negative. If it has a negative, it's basically flipping it. You may have heard this word before, but it's reflecting it. So I would say somewhere where you have space, just write that down. I don't have space. Now, in the past, like on TestNav and practice SOL things we have, I've not seen them ask about this part, but they may, you never know. So if it was like negative 1/3, it would reflect and the slope would be less steep. If it was y equals x plus 2, or I'm sorry, y equals negative x plus 2, it would reflect and the y-intercept would be moved up 2. So that negative on the front has nothing to do with the numbers when we're describing it like this. Do you have any questions so far? For number 3, they want us to plot 3 points that would represent something, on a graph that represents f of x minus 3. What is changing there? The y-intercept, and it's being moved down 3. So if your original function was this, and it's being moved down 3, it would now be at negative 3. Your slope is not changing, so that means our slope is going to stay 1, and we just need to draw 3 points, or 2 additional points with this. So if we go up 1 to the right one, and down 1 to the left one, those 3 points would work. Any 3 points would really work, and we don't need to draw the line for this, because we only need the 3 points. So be careful with questions like this, because sometimes they may let you be able to graph a line too, and then maybe it's kind of wrong because you didn't do exactly what it asked. I don't know. Do we have questions on 3? For number 4, what is that doing? What would that change? So we change the slope. And that new slope would be steeper or less steep? Steeper. So your y-intercept is not changing, so it's going to stay at 0, 0. So if you want that to be one of your points, that would be fine. And then your slope is now 2, so you're going to go up 2 to the right one, and down 2 to the left one, or however direction you want. You just need 3 points. So with these type of problems, Desmos really only helps you if you're comparing 2 lines and you want to see which one is steeper. If you don't remember about the if it's bigger than 1, it's steeper. Questions on 4? For 5, we are comparing these 2 functions. And we need to determine, has it been shifted up or down? Is it steeper or less steep? So if it's shifted up or down, what are we looking at? The y-intercept. So if we're looking at the 2 y-intercepts, has this been shifted up or down?
Up.
Up. That means for the second sentence, we're looking at our slopes. Is g of x steeper or less steep?
Less steep.
Less steep because of the fraction of 1/4. Do we have any questions about how to determine shift up, shift down, steeper or less steep? No, we as a class have never done this stuff. Well, formally, we did some of it in the SL overview. So the next page of this, they give you different graphs. And what we're going to do is graph those and also graph what would be the original and describe the transformations. So if you have like two different color pencils, pens, or something like that, this would probably be better. But you don't have to have that. Draw in the one that's given. And then also draw in your original, which is always going to be y equals x. So that would start at 0, 0 and have a slope of 1. And now we're going to compare. For the y-intercepts, what would you say about this new function compared to the original? It shifted down 5. We say the y-intercept shifted down 5. Say that again. On this part. The slope here, the number of x's is 1.
For one shifted down 5, more than the fact that
We're comparing this to this, so what did the new one do compared to this one? It moved down. Right, and then what about the slopes? We went from 1 to 6, so is the new one steeper or less steep? Steeper. And again, if you didn't know or didn't remember about the numbers, you could imagine yourself skiing or sliding or whatever down this. Which one would you get down faster? That blue one you would get down faster. For the next one, this is our original, so we're not going to draw it twice. We just draw it once. So if you get something like this or something that's similar, and the slope and the y-intercept don't change, or one of them don't change, you would just say, sorry, my brain, that the slope is the same, or the slope didn't change, and the y-intercept is the same, the y-intercept didn't change. Either of those. the original. Let's do one of these ones on here. Let's do number 5. For number 5, we need to solve this first to be able to talk about our slope and y-intercepts. So subtract x on both sides. We have 2y equals negative x plus 8. And divide everything by 2. So y equals negative 1/2 x plus 4. And that would be our new equation. So you could go ahead and graph that. Down 3, and draw in the original too if you haven't done that. If we are looking at the y-intercepts, what could we say happened? It shifted up 4. And what about the slope? Okay, so we are going to talk about the negative positive in a second, but if we're just focusing on the 1/2, how would we describe our slope? It's less steep. Now, because this slope is negative, we can say the line was reflected. Do we have any questions on that?
Okay. So I was trying to understand. Why did you say this reflected?
Because of the negative. So anytime we have a negative slope, the line was reflected. Do we want to see one more of these, or do we feel okay with these? Okay. If you're okay, then great. We are going to do one more. We'll do 6. So solve this one. So our equation would be y equals negative 7x plus 5. Graph that and your original. If we are comparing what all happened to this new equation.
So, became negative.
Okay, so how would we write that? The line reflected. What else? Say that again. About the plus. Is it less steep? Because we're not looking at the negative. We're only looking at the number.
looking at the 7.
Steeper. Yep.
So when looking at the steepness, you take out the negative, correct?
Yes. Because we're already saying the line is reflected, we don't have to look at the negative piece yet. I can also look at these two lines and I would get down this purple line much faster than this line.
What's the y-intercept? It's so little.
You did not write it. Oh, it's 4.
I'm kind of confused on trying to find the obligation. Define the place.
You just look at the y-intercept. Because it was 0 and now it's 5. Or now it's 4. Or whatever it is.
If the heading is 4, that's 8, and down for the
We divided 13. So we're looking at the y-intercept after this is done. Do we have any other questions on this? Take out your test nav SOL review. We're gonna, I'm hoping, finish that today. Does anyone need another one of those? I believe we did number 18, but not 19. So just as before, I'm going to be talking about how you can possibly use Desmos to solve this and talk through how you would do it algebraically if you need to see the algebraic part or something else. So for number 19, it's asking about the range. We need to find, if you were to do this on Desmos, you would have to put in this function. So if you have your computer, you can open up Desmos. So if we put in that function and we're looking for the range, we know it's going to be greater than or equal to 3. You have to find the lowest point. So if you tap at the vertex, it will tell you what that y value is. So be everything greater than or equal to 3. So B will be our answer there. For any domain and range questions, it's not something you could really use Desmos for unless it's an algebraic, like if it gives you a list of numbers, then you could use Desmos for that. We just looked at the graph and found the lowest point. For number 20, it's asking which function has exactly 1, 0. So that means you're looking for which of these functions only cross the x-axis once. So you could possibly eliminate if you did it algebraically, because the quadratics, you could have 2 or 0 or just 1. You would have to see all of these like that. If I graph them all and I'm looking for which one either touches or crosses the x-axis once, anything that is a linear function has to go through your x and y-intercept at least once. So the 9 times x times 8 would definitely be 1. Which other ones cross or touch the x-axis only once? The green. So I can get rid of the black, rid of the blue, rid of the purple. So only these two would be our answers. The 9 times x minus 8 and x squared minus 8x plus 16. If you factor this, you'd be looking for two numbers that add to be 16, but add and subtract to be negative 8, and negative 4 and negative 4 would be our answers. Then you would take both factors and set them equal to 0, and because they're the same number, you would end up with only 1. For number 21, you could do the same thing. Put each of these answers into Desmos and see which one is going to give you an x-intercept of 3. If you wanted to solve them algebraically, you would have to put 0 in for each of your y values and then start solving. So we are looking for which of these values goes through your x-axis at 3. Which ones do that? Green and red. Blue does not. Black does not. Purple does not. So our green and red ones would be the 5 over 3x minus 5 and the 3x squared minus 11x plus 6. I feel like I'm doing this. Oh, it's out of place. For number 22, this is something you would have to be able to do partially, and then you could use Desmos for. We would need to translate the square of the sum of x and 5 is equal to y into an algebraic equation or expression. How would we write that? Plus 5 equals y. So all of this squared is 1. Or y equals that, same thing. And then algebraically, if we wanted to, we could put 3 in, see what we get for y, and then put 4 in and see what we get for y. Or if you're using Desmos, you can put this in, make a table, put in the values of 3 and 4 and see what you get, which is what I did. So for this, I put in this function. I went to the gear wheel, I made it a table, it's disappeared now because it's already a table. I made it a table and then I put in the values 3 and 4 and it gave me 64 and 81. So our answer for that one would be C. Questions on any of these ones on that page so far?
Are we doing any of these problems from a calculator?
So if you bring your own approved calculator, yes, but you will not be provided with one, except Desmos.
Like you do.
So you would need to, put this in. I would have to redo it. And then go into the gear wheel, make the table, and then either take these out or just add to the bottom 3 and 4. But if you don't do that, then you won't lose things. So I took mine out. Okay. 23 is similar to 22, where you have to be able to write or translate this expression or equation into an actual expression or equation. So let's do that first. For what? C. So 1 more than 1/4 the square of a number, x is y. How would we write that?
1 plus b squared. That's what the number or variable.
X is being squared, we're missing something else.
24.
Or you can put y equals first. You could switch the order of the 1 and the 1/4 x squared. Either of those. Now, you could pick some x values, whatever x values you want. You only need 3 points. Put them into this function and then graph them. Or you could use Desmos and do the same thing. Put that in. It's going to give you a table of values and you can pick any of those points. So the easiest to do algebraically would be 0. If I put 0 in for x, what would be my y? Say that again. This would be 0. This would also be 0. So it would just be 1. So if I put in 0 for x, my y value would be 1. So that's one point that you could use. Now with this, because it's a 1/4, you're going to end up with fractions or decimals. They only want whole numbers or integers. So same thing. I put this into Desmos, added a table. It gave me other values, but those other values were decimals or fractions, so I ignored those because I can't plot those points. But the -2 and 2 values, we can plot those points. So -2, 2 and 2, 2. If you weren't sure of how this would look, you could use Desmos to see that this would be a quadratic. Because we're squaring something, that would also mean it's supposed to be a quadratic. So eventually this will make that U shape. with 24, so I'll read through this first. An experiment is conducted on a container of gas that is kept at a constant temperature. When the pressure on the gas is 30 pounds per square inch, the volume is 120 cubic inches. When the pressure on the gas is 40 pounds per square inch, the volume is 90 cubic inches. Let P represent the pressure on the gas, let V represent the volume of the gas. Which statement is true about this relationship? As you look at the answer, it's talking about varies directly, varies inversely. So we're trying to figure out which is which. If we look at the numbers given, as the pressure of the gas goes up from 30 to 40, is the volume going up or is it going down?
Down.
So is this going to be inverse or direct?
Inverse.
Inverse, because one is going up and one is going down. So anything that says directly, we can get rid of. Now, we have to know which of these represents our inverse variation equation. So, our direct is usually y equals kx. The variables are different, but that's okay. And our inverse is usually y equals k over x. One of these is in this format and one of these is not. I'm also going to put our equations for k. For our direct, our k is y over x. For our inverse, our k is y times x, or x times y. If this is an inverse, which of those two look more like one of our inverse functions or equations? And if we weren't sure, we could put these both in, like y equals, you'd have to change these variables to x and y because you can't graph the v and the v. But if I put y equals 4x and y times x equals 3600 in Desmos, you'd be able to see which one is a direct, which one is an inverse. Except I'm so the blue would be a direct, because it's a line that goes through 0, 0. The purple is an inverse because it does the curve. Now, with this one, because they have the same equation for both sets, direct and inverse, they're trying to trick you. So if you know what they look like, that would eliminate some of it. If you know as one of them goes up, the other goes down, or vice versa, which one it would be, that would also help you. So you have to know some of this stuff before you could answer. Desmos only really helps you find it after you know certain things. For number 25, it gives us a table and it's asking which is true about this information. So it's either going to be a direct or an inverse. However, we could eliminate some of our answer choices. If it was an inverse, is this the way we would write it? No. If it was direct, is this the way we would write it? For C? No. So we can either multiply these or divide these. It doesn't matter which one we do first. Let's say we multiply first. 1 times 10 gives us 10. 4 times 250.
9. Wait.
Was it 10? 8 times 1.25. And 20 times 0.5. So the multiplying works, so it is D. A we could have also gotten rid of because it doesn't have a y-intercept of 0. I want to say I did put this in Desmos, so you could like see the function. So I put in the values. And when you put in just the values, you see that these do not make a line. So that would also tell you, and if you put in the two equations, they give you only one matches the values, which is the inverse. But you would need to know that that's an inverse. Right. For 26, this is a direct variation. It says that. We need to plot 2 points other than the point shown to make this that are also a direct variation. The easiest point, if you get a problem like this, would be your y-intercept, because it always has to be what? 0. If you start there, then you can count your slope or count for k, and then draw another point. So what would your k value be, or your slope? 3 over 2. So if we do another 3 over 2 and plot another point right there, we have our 2 points. So if you remember, direct variation has to go through 0, 0. That's automatically one of them, and then count your slope, and you get your other. If you wanted to double check, you could write the equation of this line. This would be y equals 3 over 2x. Put that in Desmos and see if your points match up. Do you have any questions on that page? On those 2 pages? No, just that 1 page. Okay. Last 2. For 27, this is talking about the quadratic curve of best fit. So you would need to put in all of this data. I will say the more accurate this is, so like the more decimals it has, is probably the one you need to go with. So without putting this in, I could probably say D is most likely going to be our answer because it has the most amount of decimals, so it should be the most accurate. But we'll still put it in just to make sure. So there's a lot going on, so I'll explain why all of these are dotted here in a second. So I'm going to put all of these in, and you would need to be careful because some of them have decimals. You put in the wrong decimals or wrong whatever, you may get the wrong thing. If you wanted to, you could immediately jump into what is your quadratic regression equation, put that in, and see what your A, B, and C values are, and we get 1.7, 2.9, negative 5.2, so that would automatically tell us G is our answer. But let's say we forgot how to do line of best fit or curve of best fit in Desmos. So my original table was red. I'm going to change these ones because this should also not be red. Orange is good. Okay, so my original points were in red. And all of these are the answer choices they gave us. And I can look and see which ones overlap my red ones. Looks like blue. And that would also tell me my answer without being able to do the curve of best fit in Desmos. So either way, D would be our answer. Now, what I said about the decimals still works. However, if you have multiple questions with exact number of decimals, that may throw you off. You may want to put both in and see which one matches. Do you have any questions on 27?
After you put the equation in the table,
It depends on how you're wanting to solve it. So if you remember your curve of best fit equation, the -2, because I had other tables in here, but y1 tilde ax1 squared plus bx1 plus c. Mine are 2 because my table says 2. That would give you your A, B, and C value, and you can see which one matches. Or you could just put in the answers and see which one matches. 2, which part?
Do you have to type that in to get your answer?
And that's something you would have to know and remember because that's not something they give you on the formula sheet. Number 28. Now they're asking you to find the line of best fit for this set of data. They also want you to use that set of data to find the number of miles in a bus or by a bus that's been used for 40 months. So if you start putting in all of your data into Desmos, and you do your line of best fit linear regression. So again, mine says 3 because this is my 3rd table that I'm using. Yours would probably just say 1 because it would be your first table. And it would need to be, sorry, I was wondering why I had that instead of, that didn't make the way I wanted it to. These would make a line, they're not making me. But it could be a really big view. This was. There we go. So I would say be careful with your points because it says line of best fit, so you may put in your line linear regression. But if you zoom out enough, you'll see that this does actually curve, which is why I ended up using this one instead. And then I'm using this equation to find 40 months. And I didn't type this part in, but I can put in all of these numbers and write an equation. So y equals, I'm just going to use all of the decimals, so 2.25719 x squared plus 2344.28 x minus 4845.5. And I can change this to a table. So go into here wheel, change it to a table, put in the number 40. And because it's so exact, it goes over what they give us, but the closest would be the 91,400. If you're unsure of which one to use, you can look at this R2 value for the quadratics. The closer this is to 1, the better your line fits. If I did the line of best fit, it would look close, but not exactly. 1, 2. This one would also be close. They're actually the same. So I guess if they're both close like that, zoom out and see, does it keep making a line or does it curve eventually? Would be my only suggestion. but D is our final answer. I would say, I know we kind of went through all of that together, but I would say use that to go back through. Go back over how to put those in demos on your own time. Come see me with any questions you have. I'm giving you another one.